Okay, lesson 56, identifying, writing, and graphing direct variation. So, a direct variation is when an equation has only one variable that equals a variable times a constant. That equation is called a direct variation. So, the formula for a direct variation looks like y equals k, which is our constant, so that's where the number goes, times x. Now, k is a constant called the constant of variation. And you might have talked about this in science before, but being a constant means that number does not change. It is always going to be the same number every time. The only thing that changes is what we put in for x, and then what the answer comes out as for y. Okay, so a direct variation has to look like y equals some number times x. So in this first example down here, they have a table, and it's showing that the number of pitchers of lemonade you have compared to the amount of lemons it takes. So if we look at this first column, one pitcher of lemonade takes 5 lemons. If we look at the ratio of, this is y to x, the ratio is 5 to 1. So the constant of variation is 5. That means we have to multiply by 5 every time, just like in a ratio table. So if we have 2 pitchers of lemonade, now it's going to take 10 lemons because 2 times 5 is 10. Let's check the ratio. 10 over 2 equals 5. So we're good. The ratio should always be the same. If we have 3 pitchers of lemonade, 3 times 5 gives us 15, so it's going to take us 15 lemons. If we check our ratio, 15 divided by 3 is still 5. If we have 4 pitchers of lemonade, 4 times 5 is 20, and 20 over 4 is 5. If we have 5 pitchers of lemonade, 5 times 5 gives us 25, and 25 to 5 is still 5. Okay, so if we wanted to write the function rule for this table that shows us how many lemons it takes for each pitcher of lemonade, we're going to use the direct variation equation, y equals kx. And k is the constant of variation. The constant of variation is the number that we had to multiply by to get from x to y. So we know we multiplied by 5 every time. So all we're going to do is replace k with 5. So the equation for this direct variation would be y equals 5x. Let's try graphing this equation. So, we're only going to need the positive x and y area. So graph going here. Okay, so the constant of variation also works kind of like the slope. So think about, if I have 0 pitchers of lemonade, then I need 0 lemons. So it's going to start in the center. When we had 1, we needed 5. So we're going to go over 1, up 5, and we're going to make these go up a little faster. These are still going to be 1, 2, 3, 4. Okay, so then we got to go over 1, up 5 for that spot. 2 is over 2, up 10. We're just graphing these points that we got from the table over here. 3 is over 3, up 15. And we're running out of spots. 20 would be about right here, so 4 would be over 4, up 20. And then we could just connect the dots with a line through them. And that would be how you graph your direct variation equation. Now, since we came up with this formula, we can figure out, well, how many lemons do I need for 8 pitchers? So 8 pitchers, and we know that pitchers is the x value, So we're going to put 8 in for x. So y equals 5 times 8, which is 40. So it's going to take 40 lemons to make 8 pitchers of lemonade. Let's try this backwards. What if I have 47 lemons? We know that lemons is the y value. So we're going to put 47 in for y equals 5x. So now we want to solve for x. So and we have 5 times x, the opposite would be to divide by 5. 47 divided by 5 is not going to come out evenly, right? But we're going to get 5 goes into 47 9 times, and there's going to be 2 lemons left over, so we can't make more than 9 pitchers because that's all we have. So 9 pitchers would be our answer here, because we would need more lemons to make a 10th pitcher. Okay, now we are going to practice checking if an equation is a direct variation. So remember, the direct variation equation is y equals k times x. So from just glancing at these equations here, none of them look like a direct variation equation, but we can do a little rearranging to check. For example, the direct variation is always y equals, so we need to solve for y in each of these equations before we can determine if they are a direct variation. So if I want to get y by itself here, I need to subtract this 8x over to the other side. So now I have y equals negative 8x. Well, we've got y equals negative 8 is our constant of variation, and it's times x. So this is a direct variation. Yes, direct variation. That one works. Okay, let's look at this second one. Let's give ourselves a little room here. Okay, let's look at this one, second one up here. We've got y over 10 equals x. We need to solve for y. So the opposite of divide by 10 would be to multiply by 10 over 1, which is just 10. So now we have y equals 10 times x. So 10 is our constant of variation. Y equals a constant times x. So yes, this is also a direct variation. Alright, looking at this third example, we've got xy equals 6. So the way to solve for y would be to divide by x. So y equals 6 over x. So this now has y equals 6 divided by x instead of 6 times x. So no, this is not a direct variation because it doesn't have a constant of variation times x. Okay, one of the last things we need to talk about is identifying direct variation from ordered pairs. So let's write this down. Identifying, I'm just going to write dv for direct variation from ordered pairs. So we've got the ordered pairs 2, negative 14, 5, negative 35, and negative 3, 21. So just like we did up here with this table, we're just going to check the ratio of y to x and see if it is equal for each ordered pair. So we're going to check the ratio of y to x. So in this first ordered pair, we've got negative 14 is y over 2, which gives us negative 7. Now, we're hoping that the other two ratios are also negative 7 because that makes it an ordered pair. So we've got negative 35 divided by 5. That's also negative 7. Then we've got 21 divided by negative 3, which is also negative 7. So yes, these ordered pairs are a direct variation. Let's try another set. If I've got 2, 4, 3, 5, and -3. Oh, sorry, 5, 7. My bad. I was reading the other example. Okay, let's check y divided by x. So 4 divided by 2 is 2. 5 divided by 3 is 1 point. Let's get a calculator out here. 5 divided by 3. 1.6 repeating. And then 7 divided by 5 is 1.4. So these are all getting different answers for their ratio. None of them are the same, so no, this is not a direct variation. Okay, and last but not least, we need to talk about writing a direct variation equation given a point. So writing the direct variation equation given 1 point. So remember, the direct variation equation is y equals our constant of variation times x. So if you're given the point 6, 24, we don't know the constant of variation. We need to solve for the constant of variation. So we're going to plug in 6 and 24 for x and y. So 24 equals k, times 6. We need to solve for k, so the opposite of k times 6 is divided by 6. 24 divided by 6 is 4, so our constant of variation is 4. So now I can write the equation of the direct variation. Y equals k is 4 times x. Let's try this with one more point. If I have the point 2, 12, y equals kx. So I'm going to plug in 12 for y equals k times 2. So I need to divide by 2. 6 equals k. So now my direct variation equation is y equals 6x. Okay, you should have everything you need to try out the homework. Try to get a few things done. If you have any questions, make sure you ask me, and I will see you in class.